tell you one more story. Told you some stories about these, but in the exponential decay one, a lot of drugs work on an exponential decay idea. For example, you take a Tylenol, you read the back. You read the back and it says, take 2 Tylenol every 4 hours as your dose. So let's say 1 pill of Tylenol is 500 milligrams, so 2 pills is 1,000 milligrams. Most drugs have a half-life, meaning that when you take that drug, after a certain amount of time, your body will get rid of half of that drug, but not all of that drug. So for Tylenol, if you take 1,000 milligrams at 0 hours, you have 1,000 milligrams in your body. And if the half-life for Tylenol is the 4 hours that they have as their recommendation on the back, that means in 4 hours, your body will have used up and gotten rid of half of that Tylenol. So now you have 500 milligrams in your body, and you take another 2 pills. Now you're at 1,500 milligrams in your body. So you have more than you did originally. And then in 4 hours, your body gets rid of half of it, and now you're down to 750. You take another 2 pills because your headache's still there, and now you're at 1,750. And so the way that the drug works is your body gets rid of half, and then you keep adding. Eventually, you'll get to a point where you have close to 1,000 milligrams in your body, and you take 2 more pills, which puts you at 2,000, but then 4 hours later, you're back to 1,000. You will never go over that 2,000 milligrams in your body, which is a good thing, because having too much of a drug in your body can cause an overdose or cause something bad. Now, why didn't they tell you on the bottle, start with 4 pills and go to 2,000 milligrams right away? Well, it might be a shock to your system to go to that much right away, but you can build up to it over time. And then once your headache is gone and you stop taking the drug, that drug is in your body for a long time. Because if every 4 hours it cuts it in half and you were up to 2,000, 4 hours later you still have 1,000. 4 hours later you still have 500. 4 hours later 250, 125, 62.5. And in theory, your body will never completely get rid of that drug, but eventually it'll be so small or so minute that it will have no effect. But that's how they can do testing in Olympics. Because if a person has taken a drug in their body's getting rid of it bit by bit, but there will still be a trace of that. And then they can find out if an athlete has taken a drug. So lots of interesting functions here. Maybe one of these is really interesting for you, and you can start thinking about it, because maybe this is something you want to write your math essay next year on, because you have to. So for your internal assessment. Okay, but we will start with compound interest. We've had this formula before. We've looked at this formula, but up till now, we have only solved equations for time when we could use our graphing calculator. Now we're going to solve everything algebraically. Some of them are really easy to solve. You just plug things into the formula. In fact, I'm going to get you to do the first 2 right now on your own, and I'll put up the answers in a bit. You're allowed your calculator. Were you able to get $626.03? Excellent. And the next one, were you able to get $232.11? Okay, if you're not getting those answers, it might be that you're just putting something into your calculator wrong. Like if you have the older calculator and you put these things as 2 times 5 with just the hat button like this, you need to have brackets around them. Otherwise, it'll just do to the power of 2 and then multiply your whole answer by 5. But if you have the new system where the exponent goes up, it's really nice, because then you won't make those mistakes. So if you are getting different answers, then come check with me, because it might be that you are just typing things into your calculator wrong. All right, next example here. It always is really cold. So calculate the time it would take for an investment of $30 to double. We did questions like this earlier, but earlier we used a graphing calculator way of solving it. We set up our equation, so plug in everything that you know just like before, and then we typed the 60 into y1 and the right-hand side into y2 and found out where they intersected. But what's going to happen on your exam is they'll say, solve for this algebraically, if they don't want you to use your graphing calculator to solve for it. If it doesn't say which way to do it, then you are able to use your graphing calculator, and sometimes that can be a lot quicker. But what I want to point out for this one, and we talked about this a little bit earlier, is that it's going to take the same amount of time for something to double, whether it's $30, $300, or $3 million. So in this one with 7% interest, right? Remember the rule of 72 or the rule of 70? That if we take 72 or 70 and divide it by 7, so I always pick the one that's easier to divide by, so I'd use 70. 70 divided by 7 is 10. So our answer should be roughly 10 years for this to double. That's just an estimate. Now, whenever something is doubling, the first thing I like to do in an equation like this is divide both sides by 30. Or divide both sides by whatever number is there. It's going to make using your logarithms easier. And it also points out why it doesn't matter how much of an investment you have, that the time's going to be the same for it to double. Because can you see, if this was $30 and $60, when I divide by 30, I get 2. If this was $30 million and $60 million, when I divide them both by 30, I still just get 2. And it won't matter what numbers are there. If you're doubling, when you divide them, you get 2 in the end. If you're tripling, you'll get 3 in the end. And when you solve for t with this equation here, it's going to be the same whether these were $60 and $30, 60 cents and 30 cents, or 60 million and 30 million. The time is going to be the same. Yeah, if you can convince someone to lend you $30 million so you can just invest it for 7 years until it doubles and then you say, I'll give you your $30 million back, that's a good idea. It's just so hard to find those people that are willing to do that. Now, we've got our equation set up and we're trying to solve for t, and t is in the exponent. How do we solve for things in an exponent? This is an exponential equation. We take the log of both sides. And I took the log of both sides and did the log law all at once. Are you okay with that on the right side? Can you see that I took the log of the right side but then brought the exponent out in front all in one step? Yes? It's good. And then I want to solve for t, and now that you've got t out of the exponent, 12 is a number, log of 1 plus 0.07 divided by 12 is another number. You can divide by that on both sides and get t by itself. Plug it into your calculator, and 10 years apparently is a very good estimate. 9.93. And again, if you wanted to store that in your calculator and plug it back into the original equation, you could check to see if that answer was actually correct. The nice thing about exponential equations, using your calculator, you can always check in the end. Four years ago, Andrew invested some money. Interest rate was 5%, compounded quarterly. Quarterly is how many times per year? 4 times per year. The RSP is now worth $2,500. How much did he originally invest? So again, we start with our formula and plug in everything. Again, on an exam, if you were to get this question, you would get the formula given to you because it's no longer on your formula sheet. Is this an exponential equation? No. Because what are we solving for? Are we solving for something in the exponent? No. In fact, this is a really reduced, this, to be able to recognize this is a number, P, this is a number. This is like solving 3 equals 2x. That's one of your easier questions. What do? Divide both sides by 2. What do we do here? Divide both sides by 1 plus 0.05 divided by 4 to the power 16, because that's a number. And those can all be typed into, ooh, that's fancy. Go away, there. And he would have originally invested $2,049. So he made around $500 in 4 years. So if we're going to calculate the time it would take for $200 to become $500, $500 is the amount. We started with $200, interest rate of 3%, compounded quarterly. Now we're solving for time. Time is in the exponent, so we can use our logs. Could take the log of both sides. Let's say this time you decided not to divide both sides by 200 first. Okay? Personally, when you have an extra number out in front and a number on both sides, I like to divide both sides. It makes your equation go a little bit quicker. But if you didn't do that, you said, oh, t is an exponent, I know I have to take the log of both sides, and you did that right away. What do we have to remember here? We have to remember that this exponent of 4t can't come out in front right away. You're going to want to do that right away. But that 4t is only to this. There's a multiplication in between the 200 and the 1 plus 0.03 over 4. And we have to first use the log law that says when you multiply, you add. And then you could bring that, right, that 4t could then come out in front after you've done that first log law of when you multiply inside of a log, you can add those two logs together. Now we've got t out of the exponent. Now it's just a matter of getting t by itself. You can subtract log of 200 on both sides, and then divide both sides by the 4. No, because we could type, you could if you wanted to. but we can type this in all at once. If you simplify the top part, you get 500 divided by 200, right? You could do that, no problem. And that simplifies just to 5 over 2. And when I type this into my calculator, I'm going to show you that whether I'm going to use my fraction button, whether I type in log 500 minus log 200 divided by 4 log 1 plus 0.03 divided by 4. Whoa. Again, an important thing to do, especially as you see here, as I'm typing it in, I forgot a plus sign. Before you push enter, just make sure that your equation that you've typed into your calculator matches the equation that you want. Because I'm going to push enter and I'm going to store this value and check it to see if it actually works. So according to this, it's going to take 30.66 years to go from $200 to $500. So a reminder, you can store that as x, and then we can go back to our original equation. Our original equation on the right-hand side was 200, 1 plus 0.03 divided by 4 to the power of 4t, and I'm going to put x in there because I've stored it as x, and I want to check, does this equal 500? And since it does, I know that my answer is right. Now, Cameron was asking, could we combine our logs as a single log on top, which would give us log of 500 divided by 200, which gives us log of 5 divided by 2. If I would have done that, on the top of my fraction, I would have had log 5 divided by 2 instead of log 500 minus 200. And on the bottom, I would have the same thing, which is 4 log, oops, don't need that extra bracket, 1 plus 0.03 divided by 4. And notice that we get exactly the same answer. In fact, that should make sense because if you had started off by what I suggested before, always dividing first, if you have a number here. If I divide both sides by 200, can you see that my equation would have been 5 over 2 equals 1 plus 0.03 divided by 4 to the 4t. And if you would have taken the log of both sides, you would have been right at this step later on anyways. And your question would have been a little bit quicker because you wouldn't have had to write so many logs. So I always recommend, if you can, divide at the beginning. All right, we're going to do one more example. Calculate the time it would take for an investment to triple if it's compounded monthly at a rate of 5%. So the initial hang-up that people get on this question is they're like, they didn't tell me how much money. Doesn't matter. So you could pick any amount. If you picked $1, then tripled would be $3. That's the easiest one. But you could pick any amount, and then it's 1.05 compounded monthly. And then solve for this. And what did you guys get? 22 years?